basically we're gonna talk about some things that are just gonna finish up the systems section with us or for us, and then we'll watch a short video, and then we'll do our quiz review. So anyways, so if you go into your Google Drive, and go to our lessons plans, week 4, day 1. We'll start with this PowerPoint in there. So this just last week we talked about MELs and CDLs, what they were. Does anybody remember what MEL stands for?
Minimum equipment list.
Yes, sir. So MEL is our minimum equipment list. Basically, it's a list of everything on the aircraft and the limitations if it was to break or go out of service. So what restrictions it places on the aircraft when certain things break on the airplane. Believe it or not, a lot of the planes that you fly on, it's got a broken part on it. Doesn't mean that it's, unsafe. Just sometimes there are certain restrictions that it places on the aircraft that we need to take into consideration when planning the flight, and the pilot needs to take into consideration when he's operating the flight. So when we talk about the systems, the dispatcher needs to understand how systems work, and if there's a component fails, what's the penalty? So what do we take off, or what's the penalty when something breaks? So a lot of it is we kind of categorize into one or two different into two categories. Safety item, or is it more for passenger comfort? First off, talking about the pneumatic system or bleed air. Remember what the bleed air is supplying air to. The first thing that it's supplying air to that we need to take into consideration is, the bleed air is used for engine starting. It's used for anti-ice. It's used for the ECS system, or environmental control system. So we're talking about like air conditioning and cabin pressurization. And so, it's kind of an important system. So some of the things that we need to take into consideration if there's a problem with the bleed air is a lot of times we're going to take a penalty hit on takeoff. It's going to be a loss of thrust. Whenever we have to turn the bleed air on when we're taking off, it's going to extend how far it takes the airplane to get off the ground. And that's because what the bleed air is doing, if you remember, is it's taking air off the engine at certain stages and feeding it into the pneumatic system. So whenever we turn on that bleed air system, it's sucking air out of the engine. And as you can remember, the jet engine, the main supply of, one of the main ingredients to producing that thrust is air. And so if we have to pull air off of it, we're gonna lose that thrust. So think about it like when we have to use anti-ice. If we have to use anti-ice on takeoff, it's going to be a loss of thrust. If there's an MEL where we have a valve inoperative that requires us to use bleed air on takeoff, we're going to have the loss of thrust. Anytime that we have to go out of our standard configuration, we're going to take a penalty. So, could have a weight reduction, could have altitude restrictions, and then the biggest one that really, really, really affects us as dispatchers. What if one of our anti-ice systems is inoperative? Well, all of a sudden we have what we call a no icing aircraft. Does anybody remember? I talked about this one day in class, but does anybody remember the ingredients for ice? Like, what is or when can icing occur?
When it's 10 degrees Celsius and you can see moisture in the air.
Yeah, so 10 degrees Celsius and visible moisture. And visible moisture is things like clouds, rain, any type of precipitation, fog, haze, mist. And once again, talking about that, we're going to hit that in meteorology pretty hard, but I want to show you guys real quick. I just want to show you guys really quick of where ice is being forecast across the country. Oh man. There we go. So this will give you a taste of how much no ice can affect your flight. So these are icing areas where they're forecast to have icing. Okay, that's not taking into consideration. This is talking about, moderate icing. So these are areas in the country. Look how big it blocks out. And think about our major hubs and where they're located. This is a fairly big problem. And I'll zoom in for you guys here. I'm wondering. Anyways, this is just forecast icing conditions. And this is flight level, from the ground to 20,000 feet. So, but this is, not including all the clouds in the sky or anything like that. So this is just forecast icing conditions. Okay, our major hubs: San Francisco, LA, Seattle, Salt Lake City, Minneapolis, Chicago, O'Hare, Atlanta, and then up here. But think if you have to fly to San Francisco from pretty much anywhere in the country, it's kind of a pain to get to San Francisco. Huge add-on to our gas. Now let's look at where the clouds are. Trying to dive in and out of these clouds and get through, it's going to be kind of a nightmare. So, no icing aircraft is a pretty big deal when we're dispatching. We have to make sure that our route, we'll keep them out of icing conditions the best we can. And then we have to throw on a crap ton of fuel just to make sure that, if they do encounter areas where they need to deviate from our planned route, then they can do it without, having to worry about gas, the fuel. So that's probably the biggest one with bleed air. With the pneumatic system is, no icing condition. And I would write that down. Just say bleed air MELs. Main problem is going to be an icing condition, because that will be on our test. Some of the other issues, I'd just say it affects takeoff performance and is, possibility of loss of thrust. So, altitude restrictions as well, kind of a big one. So that's the bleed air. APU. We've talked quite a bit about the APU, but we need to make sure that if the APU is out, then we have both IDGs. We're not, if there's an IDG deferral and an APU deferral, we can't have both. One of them's got to be fixed, right? So remember that the APU provides the AC and electricity on the ground. Then it provides the bleed air to start the engine. And then it's the backup. It's auxiliary, right? Auxiliary power and auxiliary bleed air. So if it's deferred, we're most likely going to take a pretty significant weight penalty. Depending on the airport that you're taking off from, it could, you could be bumping passengers. The arrival airport, we talked about this one a lot. The arrival airport needs to have a GPU to start the engine, right? And if it doesn't, then we can't fly there because then our airplane will just get stuck. And then don't dispatch to a hot airport. So why do you guys think that we wouldn't want to dispatch an APU out to a hot airport?
The air's thinner.
Already have the potential for a weight restriction. When you couple that with a weight restriction at a hot airport, it might leave you with like 3 passengers.
Yeah, so that's one of the big ones, right? Could take a huge weight penalty at a hot and high airport. Remember, engines don't like hot and high. What about passenger comfort? What is it doing on the ground?
It's creating a vomit comet.
So on the ground, it's going to be extremely hot because they don't have the engine running yet. So the APU is providing that bleed air while it's sitting on the ground, and the bleed air controls our environmental system, right? So it's going to get extremely hot inside the aircraft. Have you guys ever been in an airplane and as you're getting off, they're like, please close the window shades on the airplane?
Often, yes.
Yeah. The reason why is because it just gets so stinking hot. It's a greenhouse inside that airplane. You're in this metal box, right? So if you don't have any AC power and you don't have any bleed air sitting on the ground when the engines aren't started, you know, it's like stepping into a 120-degree car. Everybody just instantly will start sweating. You'll have people getting sick, you know. It's just bad news all around. So that's the issues with the APU, and I'd write down the deferred, like if it's deferred, what's the problems? Remember, weight penalty, need a GPU to start the engine, and you don't want to go to a hot airport for a couple different reasons. But number one's just the performance hit, but number two would definitely be the passenger comfort. It's kind of funny that you say the vomit comet. Let's see if I still have this.
When we had the CRJ 200s doing the shuttle back and forth from Flag to Phoenix in the summer, it was just unbearable. I felt so bad for the flight crews that then had to go to Palm Springs or had just come from Palm Springs.
Yeah.
The term vomit comet comes from them.
Yeah, it's I've been in an extremely hot airplane and I've had to experience like your stomach is already queasy, then you hit turbulence, it's like it's over. You know? And I really want to find okay. Just found it. Here. So actually, I'll pull up the news article. I want to make sure that I find the actual PIREP. Because it was pretty funny. Okay, here it is. So this was one of our dispatchers. We're able to file what we call PIREP, a pilot report. And do you guys remember the nor'east storms that hit this winter? It was about end of February, beginning of March sometime. Basically, it was like a really bad storm that hit the northeast coast. Well, this was a plane that was flying into Dulles in Washington, D.C., and this PIREP here one of our dispatchers got an ACARS that said kind of this, and so they immediately published a PIREP. Well, a PIREP is national, like, public information. And it got picked up so quick. And if you look up Dulles vomit plane, you can see there's like 3 pages of articles from different news sources. And it's all about this. But this was one of our planes. So this says urgent upper air PIREP over Dulles International. Time was 12:38 Zulu. Flight level 4,000 feet. Type CRJ 200. Moderate to severe. Very bumpy on descent. Pretty much everyone on the plane threw up. Pilots were on the verge of throwing up. So I get this message from the dispatcher that wrote this report. And they were like, just a heads up, it's going to be crappy, because I had a flight coming in right behind it. And they were like, you'll want to inform your pilot of how bad the turbulence is. So I told him, hey, just a heads up, PIREP, and gave him the PIREP. And he busted up laughing. And yeah, basically they had to go in and scrub this whole airport down, or airplane down. They pulled it into a hangar and scrubbed it down because of how bad it was. But yeah, people were like puking all over the place. Pretty bad. But yeah, her PIREP, she got questioned pretty hard by management about why she wrote the PIREP, and because it's not professional language or whatever, but kind of funny. I just
You professionally word that.
I don't know, but yeah, United. I mean, their phones started ringing off the hook because it was a United, you know, SkyWest United Express flight, and so they got, and we were getting phone calls from the press like crazy, wanting to know more. And anyways, all kind of funny. But and I've experienced severe turbulence on approach into Salt Lake, and it's scary. I just can't even imagine like the entire plane filling up with puke. That'd just be so nasty. It had to stink so bad. But so the AC packs, we talked about these a little bit. The important things to remember is that we can still operate. We have two AC packs, a left and a right, and we can still operate with one of them not working. Okay, and it won't affect the flight as far as like it doing its job, but it does place an altitude restriction. So remember, the packs are providing our air conditioning and the pressurization. So one pack can pick up the entire load, altitude restrictions, and then the air conditioning isn't as effective. But if they're both deferred, which basically they won't let us operate, but technically you can. You just have to fly unpressurized below 10,000 feet, and most of the time we just cancel the flight because of that. You definitely want to be operating the flight. If you were to continue to operate the flight, you'd want to be in a cooler environment, and it would have to be extremely short hops. We're talking like Chicago to Milwaukee, kind of a short hop. So, yeah, pretty bad. Typically, we just shut down the plane and take it into maintenance to get fixed. So the continuous ignition switch, the big thing to this is that what it's doing is the engine will provide continuous power if it's turbulent or icing. So it's constantly firing, right? If it's deferred, can't go into turbulence or into icing conditions. So these ones, a lot of times we just don't operate, and if we do, it's to get it. We'll do what we call a ferry flight or a maintenance reposition flight, and it's just us coming from one of our outstations to a main hub or to a maintenance base to get it fixed. Because of how hard it would be to operate an aircraft if it couldn't go into a turbulent or icing condition. So, kind of a big deal, right? I mean, pretty much every flight that you go on, you experience turbulence at some point, right? So, a couple of deferrals that we need to take into consideration. So for if our nose gear steering is deferred, we can't operate a revenue flight. They have to tow it out to the runway and then take off if they're going to be taking off. I believe believe it or not, we actually do have this happen. We'll do gear down flights where they'll keep the gear down the entire duration of the flight to get it to maintenance base. If the anti-skid deferred, what do you think the anti-skid system is? I mean, we kind of talked about it, but
It keeps the aircraft from skidding on landing.
yeah. So kind of think of it like your ABS system in your car, automatic braking system. It basically just prevents the wheels from locking up when you land and apply the brakes. So if your anti-skid's deferred, you can't have a contaminated runway, which means that you can't have like snow or standing water or slush. And then you take a huge weight penalty for an anti-skid deferral. If you're going to like a smaller airport, a lot of times you're going to be bumping passengers when you have an anti-skid deferral. Because basically they can't apply the brakes very hard, and they have to rely heavily on the thrust reversers to slow down the airplane. So electrical systems. So we have 3-phase AC, our IDG, integrated drive generators, or the CSD, the constant speed drive. Remember, that's like the transmission. If one of our IDGs get deferred, basically we have to keep the APU running continuously in flight. Okay, which that means that we have to take a performance penalty, first of all. Second of all, that's also going to increase how much fuel we have to put on board, right? Remember the APU, and I want you guys to definitely write this down if you haven't already. The APU burns 260 pounds of fuel per hour. That's on top of the engine burn, right? That's in addition to. So, that can be quite a hefty little bit of weight there. I mean, that's a person per hour that you could be bumping potentially. Then also altitude restriction. So with the 700, what does anybody remember what the altitude restriction was for the IDG and op? Bueller.
Was it 30?
You're close. So it's 31,000 feet. Yeah. So
I look to my right on my notes and it says, if only one AC is functioning, flight is limited to flight level 31,000. It also happens to say the APU burn is 260 pounds an hour. So I'm
awesome.
not going to watch this screen. I'm going to look at my other one.
Awesome. I'm sorry. I think I might have got that wrong. It's actually, I pulled up my list here. So with the APU, it's 32,000 feet. APU continuous burn. That's 32,000 feet. The AC pack deferral. So if we're operating with one AC pack, we're going to be limited to 31,000 feet. So I got them backwards there. IDG, 31,000 feet. APU, continuous burns, IDG, 32,000 feet. If an IDG is in op and we have to run the APU continuously, 32,000 feet. 32,000 feet, 32,000 feet. Okay, one pack deferred, so we're operating with one AC pack. That is 31,000 feet. My bad. So it's probably the most common problem that we have with the electrical system. I would agree with that. Either the CSD is deferred or the IDG. So fuel system. Remember that the CRJ is fueled with what we call single point refueling, single point pressure refueling. Okay, so that means that they hook up the nozzle for the gas to one point and it fills all three tanks, right? Because we do have a tank in each wing and a tank in the center of the plane. Okay. So if the single point refueling valve goes out, we have to do what we call gravity or over the wing fueling. Okay. This means that they have little gas caps on top of the wing. They've got to go and open those up and fill each tank individually, which also means that they can't fill the center tank because the only way to fill the center tank is through that single point refueling spot valve. They can only fill the two wing tanks. So you lose the the center tank. Which means that you're going to lose a pretty decent amount of fuel capacity. I can't remember the exact amount for the 700. I know that the max fuel that we can take on a 700, so all three tanks full is 19,594 pounds. I think with the center tank deferred, the single point pressure refueling deferred, I think we have to take away like 10,000 pounds, somewhere in that neighborhood. So we're only able to carry like 9,000 pounds of fuel. So take a big hit there. And then you also need qualified people, stuff like that at the station. So if you're operating in Fargo or International Falls or what's CMX? I can't remember the name of the airport.
Houghton.
Yeah, Houghton. Places like that, you may want to have the controller double check that they have the ability to do over the wing fueling, because that is a special certification. All right. So here's our navigation equipment. This one is huge. Screenshot this, take notes on this, because it can be, this is where your role as a dispatcher is really going to come into play. I mean, these are ones where you're going to pull out some dispatch school stuff to figure out how to plan the flight. Weather radar. So weather radar, we can't dispatch into thunderstorms or hazardous weather. Okay. If they can't see what's going on in front of them, bad day. They need to be able to see, precipitation and stuff like that, storm intensities, tops of clouds, things like that on their weather radar. So, weather radar, you don't want that to be deferred. FMS, this one is probably the most notorious in the dispatch world. When people say they have an FMS deferral, everybody goes, oh boy. And it's really not too huge of a deal, but it always sucks when you have a FMS deferral because you cannot use any satellite-based navigation at all. You have to plan the flight using what we call green needles. So all ground-based navigational aids. And when we say green needles, it's referring to the actual instrument inside the airplane. If you guys remember the VOR receiver, the ADF or whatever the instrument has two sets of needles. So when it has the satellite and the VOR navigation, one set of needles, I believe the satellite navigation needles are red, and the ground-based needles are green. So they can navigate using those, but they have to, when we say a green needles route, it has to be solely done by the green needles ground-based navigation. So so you typically have to go in and plan the route, like build a route for that one. So your flight plan takes quite a bit longer than a standard flight plan. So autopilot. Remember, autopilot's required to go into RVSM airspace. Do you guys remember what RVSM airspace is? And possibly what altitudes are associated with RVSM?
RVSM is reduced vertical separation minimums, and that airspace requires separation of 1,000 vertical feet between flight levels 290 and 410.
Perfect. Yeah, perfect. So basically, if the autopilot's deferred, we can't fly above 290 because that is RVSM airspace. Cat 2 approaches. We've talked about Cat 2 a little bit, but basically they're reduced minimums. And it goes, our standard ILS minimums are going to be 200.5 mile, right? That's what we've drilled into your heads. A Cat 2 approach is basically half of that. You can go 100.25 miles. So reduces your ceiling by 100 feet and reduces your visibility by half a mile. So, at times that's pretty important to have. If we have weather impacting an airport, we may not be able to operate the flight with that aircraft. So VHF, we have to have two VHF radios working on the airplane. If we don't, can't operate the flight. GPWiz. Remember, GPWiz is the one that's like notifying the pilot of terrain issues or wind shear. If a GPWiz is out of service, can't do any takeoff or landing in known or forecast wind shear. And we'll talk a little bit more about what wind shear is, but if our TCAS is in op, basically we just have to advise air traffic control, and the way we do that is in our strip, in the flight plan strip that we send them. There's TCAS. You just have to make sure that that ATC understands that there's no traffic advisory system working on the aircraft. They can still, a lot of pilots will call in and be like, oh, I can't operate in RVSM airspace, and you have me planned at 32,000 feet with the TCAS in op. And it's like, no, that's wrong. You can still operate in RVSM airspace with the TCAS in op. So you just have to advise air traffic control that your TCAS isn't working, and they have to provide separation for you while you're in the RVSM airspace. DME have to have one working at least in order to dispatch the aircraft. What's DME stand for?
Deferred maintenance item. No, that's not right.
Distance measuring equipment.
Deferred, yeah.
Distance measuring equipment. Yep.
DMI is what I was thinking of.
Yeah.
That's a totally different thing.
Yeah. But anyways, so those are some of the common MELs and some of the things that we need to do or take into consideration when we're planning those flights. Those are pretty much the main ones. Everything else that we see as dispatchers typically isn't going to be something that we really have to plan with, right? It's just going to be more for information. So, I get a lot of MELs for, passenger seat reclining or passenger tray table or, cabin trim, stuff like that. Those kind of MELs or NEFs, we just don't even worry about. We just doesn't affect the aircraft. It's more there for information than it is for we have to do something about it. So there's a couple more that as you get to the airline will be more aircraft specific. One MEL that we have, actually it's a CDL that I deal with probably on a daily or every other day basis, is what we call aerodynamic sealant. And it's a sealant that's applied in certain parts of the wings. And if there's if there's any missing, they have to write it up because they take a weight penalty for those. And I actually have to go in and manually input the weight penalty into the system as I'm planning the flight. So there's certain things that you're going to pick up on when you're actually at an airline that we don't really cover here because of the nature of the MEL, but pretty much any aircraft is going to have very similar restrictions. If the pneumatic system's not working, well, the pneumatic system on 99% of the aircraft that turbine aircraft out there, guess what the pneumatic system operates? the ECS. It's going to operate anti-ice. It's the bleed air supplies the engines for engine starting, things like that. I mean, it's going to be basically the same. So these are the main ones that we will see in dispatch as we are out there, regardless of where we're at. So that's pretty much it. So this video, there's two of them in here. Oh, okay. So this video that I want you guys to watch, it's 29 minutes long, but it's a video about the principles of flight. And we'll come back on and we'll talk about them. But it's in your Google Drive, or I just pasted it in the chat window. But it goes through the basic principles of flight, and I want you guys to watch it, and then we'll get back on and we'll kind of do a review on it. Actually, after the video's done, so the video will take you guys to 7 o'clock. Why don't we take a 20-minute break on top of that for dinner? So once you guys are finished watching the video, can take a 20-minute break, and we'll get back on at 7:20. We'll do a review of what you saw in the video, and then we'll do quiz review. Sound good?
Sounds good.
All right. Enjoy the video. All right. So, what did you guys think about that video? Is anybody back?
Mine stopped at like 20 minutes.
It stopped at like 20 minutes?
Yeah, I just like blacked out after 20 minutes.
That's really weird.
It said end of lesson 1, and then it just was black after that for 9 minutes.
Oh, boy.
Yeah, mine did the same.
Mine didn't.
That's
really
strange.
But I watched mine on my YouTube app on my TV. So.
Oh, nice. Yeah, so the first part of it that you guys were able to watch talked about, how wings generate lift. It talked about some of the flight characteristics, right?
Yeah.
What questions do you guys have about any of that, or? No questions?
I did have a question.
Mm-hmm.
They talked about the 4 types of drag. Form, skin friction, induced, and parasitic.
Mm-hmm.
And when they talked about induced drag, and they were talking about wingtip vortices and the length and angles of the wing.
Mm-hmm.
And we had talked a little bit about winglets before, and you had mentioned how in the past, before the winglets were added, that like the first like half to 2/3 of the wing were the only usable portions.
Mm-hmm.
Is that related at all to induced drag?
Yeah, that's exactly so.
Okay.
That's actually, I would categorize that more as parasitic drag, but
Okay.
but induced drag, or the wingtip vortices. So, it talked about the speed of the air flowing over the wing versus the speed of the air flowing under the wing. And if you really want to get into the nitty gritty of, airfoil design, look at Bernoulli's principle, because that's exactly how we came up with, they originally came up with wing shape and everything, was because of Bernoulli's principle. But basically it's shaped to create a and I just lost it. It's shaped to create differences in pressure, right? And that's what creates the lift, is basically the air ends up holding up the aircraft rather than, than what some people may think as far as lift. The air's holding up the aircraft, almost like a ship is buoyant on water. That's how an aircraft becomes. But yeah, the drag, those wingtip vortices, because of the differences in pressure and because of the way the air is flowing over the wing, what happens is it generates those vortex off the end of the aircraft. And as it goes out to the more narrow part of the wing, then we get more and more of that wingtip vortice that you see. You can actually see it when you watch an aircraft take off. And let me see if I can pull up a video. Especially if they're
on that. In Ash's defense, the video does say that the wingtip vortex is induced drag.
Oh, it does?
Yes.
Okay.
As opposed to parasitic being the
antennae and other things. But
wheels.
I have to say that, and I'm ashamed to say it, in all my, I'm not going to say how many years, but I'm a non-rev baby. I took my first flight when I was 3 weeks old. My dad worked for the airlines. I have grown up in aviation. It's been my primary career path for all of my life. And watching that was like the most I have learned about the miracle of flight ever in that 28 minutes and 29 seconds. So I'm a little bit ashamed to admit that, but it is what it is.
Yeah, it's really
And
interesting, the science behind it.
It also gave me a very good, a better visual of gyroscopic effect, which we talked about the other night.
Mm-hmm.
That I wasn't quite clearly understanding, other than it sounded like a very scary terminal illness.
Yeah. Yeah, it's pretty interesting,
Yeah, it did. It
going
gave me
through the science of this.
I was better able to understand it.
Yeah. So here's what, these wingtip vortices look like, and I'll pause the video when we get. But we especially see it. Do you see the aircraft right now? You can see the vortices coming off of it right now.
Yeah.
But look how far into the wing they are, right? They're being created. Right. They're being created at the end of the flaps. And this is an aircraft with winglets, so it's pretty cool to actually see it happen,
Yeah, that is really cool.
Let's see. And the reason why you're seeing it on this aircraft so defined is because it's actually being caused by the flaps. And he's going really slow. So Let's see, when he passes him, you should get a really good view of it. Not as good as I thought. So it's interesting when you're flying. When, especially in little aircraft, the vortices and coming off the aircraft are extremely dangerous because it's called wake turbulence. I don't know if you've ever heard of the term, but what happens is you have these larger aircraft that are generating huge vortex of air, and it's like a washing machine. And you fly a Cessna 172 behind this aircraft at a lower altitude than this aircraft flew, even if you have a difference of 1 or 2 minutes between the larger aircraft and the small little single prop, personal plane, it turns the 172 into a washing machine and is extremely hazardous. So when air traffic control is directing aircraft into, and this is just a side note on top of, since we're talking about wingtip vortices, but you'll actually have air traffic control call in when you have a smaller aircraft on approach, and they'll say, caution, wake turbulence. Cleared to land, caution, wake turbulence. So, when you're a smaller airplane, you really pay attention to that, and you pay attention to where that jet touched down, because what you want to do is you want to come in higher and land further, they call it land longer than the aircraft in front of you. Once you get onto the ground, they dissipate pretty quickly. But, for miles, they leave this just washing machine of air. And there's been several aircraft accidents caused by wake turbulence.
And it actually drops below
yeah,
for quite a long time.
Yeah, it'll just sit there above the ground and just circulate. But you have that problem, especially with large aircraft that are going at slower speeds. So, basically you don't want to fly anywhere below the path of the larger aircraft if you're in a smaller aircraft, because the vortices travel down and away from the aircraft. So, but kind of interesting how it all works. I actually had a friend that flew for the Civil Air Patrol, and they had their 172. They were flying up in Salt Lake, and they had a larger jet land right in front of them, and he said that they were trying to land longer and everything. He said, but he still got caught by it, and it flipped his aircraft upside down. They landed upside down just on the side of runway 14, which is kind of the diagonal runway in between the two larger runways up in Salt Lake. And he said, luckily, they were going slow enough and they were low enough to the ground, but luckily everyone walked away from the crash. But yeah, pretty insane. But yeah, you guys learned about the 4 forces that act on an aircraft, right?
Yeah, thrust, drag, weight, and lift.
Uh-huh. So this is kind of the funny version of that in aviation. Oops. Dreams, money.
Oh my God, wait, I want to
reality.
screenshot that.
But yeah, so, you know, some of these principles are fairly basic, but extremely important in aviation. And like it said, these are the general principles of flight in the video. So, yeah, really important stuff. One thing that I wanted to talk about really quick before we get into the review was different takeoff speeds, and I don't have anything special as far as a PowerPoint goes on but let's see. But we're going to talk about a couple of these V speeds, or what we call them. I just want to find a visual aid to help me do that. So these are our takeoff, what we call V speeds. V stands for velocity, right? So we've got V0, which is just standing still on the runway, ready to take off. We have V1, VR, and V2. Okay. So you'll hear these are actual callouts that pilots do when they're taking off. They'll also do one depending on what aircraft they're flying. In the CRJ, they'll call out 90 knots. But what these speeds represent, so V1 is what we call takeoff decision speed. Okay, and I want you guys to write this down. Pretty important. Okay. Just 1 second, sorry. I'm trying to see if I can find a couple more things here. I'm sorry. Yeah, so this is so V1 is our decision speed. So this is the point at which, if they need to abort the takeoff, this is the point where they have to make a go no go decision on takeoff, right? So as they're approaching V1, they're watching, and depending on who's flying. So the PIC, the captain, and the first officer, they take turns on who's actually, doing the stick and rudder part of the flying every flight. So the one that isn't actually stick and rudder and when I say stick and rudder, they're the ones that have the actual flight controls in their hands and are inputting these different things in order to make the aircraft fly, right? So if they're not the one doing the stick and rudder, they're monitoring all the systems. They're checking oil temps, they're checking their speed, they're checking their heading, they're watching and making sure that everything's safe. They're scanning the horizon, making sure they're not going to be hitting birds and crap like that. They're monitoring the N1 speeds. Like, they are just looking for everything that could go wrong, right? Once they hit V1, at that speed, they call out V1, and the pilot that is doing the stick and rudder has to decide at that point, am I going to take off or am I going to abort the takeoff? This is the speed at which they can safely stop by the end of the runway, okay? So at V1, if they need to abort, they will pull back all the power and they will slam on the brakes basically and get the airplane to stop before they even get off the ground. Okay. VR is rotation speed. So this is the point at which the pilot in command or the one doing the stick and rudder stuff, he'll actually apply the back pressure on the stick and lift the aircraft. He'll start the rotation to lift the aircraft off the ground. V2 speed is known as takeoff safety speed. Okay, so this is going to give us at V2. Basically, at this speed, the aircraft can climb safely with one engine in op. So this is the speed where once they hit this speed, they know they can climb to altitude with one engine not operating. Okay. So it's the quote unquote safe speed, right? Takeoff safety speed. So the names of the V speeds, V1, and I want you guys to take note of this. V1 is takeoff decision, right? VR is rotation, and V2 is the takeoff safety speed.
Is there a name for V0?
No, we're not worried about V0. V0, nobody ever calls out. It's just they're lined up on the runway.
Copy, thanks.
Yep. But the V1, VR, V2 are audible call outs, and those are the really important ones on takeoff. Now there's, dozens of other V speeds. V1, VR, V2 are the very important ones that we need to know. A couple other ones that are more for just reference that you may hear used is VFE, so Victor Fox Echo, Victor Foxtrot Echo. That is what we call maximum flap extended speed. So this is the maximum speed in which they can start extending the flaps. Okay. Let's see, I'm trying to think of any of the other ones. Trying to think, is there any other really important ones? So that's pretty much it for V speeds, but super
Garrett.
important. Yeah.
Sorry, is there somewhere on this chart that VFE would be displayed?
No, that would be mostly used on landing. So
On land. Okay.
yeah, so the reason why I bring this up is because when we're doing flight planning, we actually have one of our performance charts. Oh, VREF. Okay, so so you can see when we're planning the flight, we'll actually write down our V1, VR, V2 speeds. Okay. We actually, depending on the weight of the aircraft, and that's pretty much it. Depending on the weight of the aircraft and the temperature outside and the altitude, well, I guess that wasn't it, but okay, this is our flap setting, okay? We tend to take off with flaps 8. In this class, we will always plan at flaps 8. Did somebody have a question? So we always will, in this class, we'll always plan to take off at flaps 8, depending on the pressure altitude outside. And for this, we're just going to use the altitude at which our departure airport is. But depending on the elevation of our departure airport, that's going to determine which column we look down. To determine the row, we're going to look at our outside air temperature. Okay. And that's going to dictate what speed we operate these different things. So our takeoff decision speed will change according to those different things: the weight of the aircraft, what flap setting, the altitude, and the temperature. Okay. VR, same thing. V2. Okay. On landing, this V reference speed, this is the speed at which they'll be flying before they extend the flaps. Okay, so VREF, when they go to 8 degrees flaps, they need to be at 138 knots. 20 degrees, 132, 128, 120. Those are the speeds at which they extend the flaps. Okay. The reason why these speeds are important to the pilots, not as much to the dispatchers, and when we plan, the computer's going to, actual practical application, when we do the planning, the computer's actually going to calculate the V speed for us. But the reason why these speeds are important is when you're taking off, if you rotate after the VR speed, so you're taking off further down the runway than you're supposed to, it actually will increase the time it takes to climb out, which means that you're going to burn more gas and things like that. So these pilots need to be paying attention to these speeds, not only for safety, but also because these speeds determine, performance and stuff like that. Not a huge impact on performance, but at the same time, an impact nonetheless. So,
is a gear extended VGE, I believe, is that
yeah.
maximum?
So, yeah, that's the gear extended. Exactly.
Is
So,
that one?
sorry, go.
Is that one that we should know as dispatchers?
No, not really. The only ones we're really concerned with are those V1, VR, V2 as dispatchers. The VREF speed that I showed you, that's more pilot stuff. But on that chart, I'm just showing you that it is something that we will calculate for performance reasons, right? So, yeah. That pretty much takes care of those. So I think we're ready to start the review. So on this quiz, I'm going to record it. I'm thinking that I should maybe try having everybody jump off again and then recording it. I don't know what happened last time. I don't know. What do you guys think?
Sure, that's fine.
Okay. I'm going to end the session. Oh, what?
I haven't listened to any of the recordings, no, any of the reviews or quiz reviews at all. Obviously, the one wasn't recorded, but I think the key is in taking and reviewing the notes and making sure that our notes are.
Yeah, definitely. That's the number one for sure. I'm going to just end this meeting and we will jump back on. Give me about 5 minutes to make sure that like the video for what we've already done is kind of out of the way and not clogging up my computer. I think that may have been the problem, was it was trying to decode two videos at once. So convert, two videos at once. So let me end the meeting for all really quick. Let's just plan on jumping back on at let's say 8 o'clock just to make sure that everything's set, and then we'll start the quiz review. Sound good?